Hey, welcome back. I got a new tutorial for you guys. I'm gonna kind of stop with the reversing for a bit and kind of focus a little more on creating your own security tools or hacking tools, or whatever you want to call it. I'm gonna start simple with a quick, literally a 5-minute keylogger that you can write yourself and customize and do whatever you want with it. Super simple. But eventually we'll expand on it and try to make it kind of cool. But for today, I'll show you how to just get the kind of basics down and get the keylogger up and running for a Linux system. The first thing you got to do is you got to actually find the character driver associated with your keyboard. You can find that by checking proc bus input devices. So I'm going to cat it and pipe it to more. I know which one mine is already. Yeah, it's the very first one, AT translated set to keyboard. So check the name, look for something like that. Look for something, keyboard, AT keyboard. It may not be exact. I've got a laptop, I don't know. But what we're interested in is the actual the handler, which is event 0. So that's actually a character device driver, event 0. And it's actually in dev input. And you'll see all the event handlers. Event 0 is what we're interested in. So what happens is the input system in Linux will deliver events to this character driver, which if you're root you can read, and those events are essentially key presses, which key up, key down, and you can get the data, so you can get the actual key that was pressed, which obviously enables us to log the keystrokes. So real quick, we'll call it keylog.c. I've just got to include some header files real quick. Just ignore this for a second. This and one more. Going to define a constant for our log file. Call it where we're going to actually store the data. Call it /tmp/data. We're going to need a structure input event. You can actually read about that in this header file. usr include /linux input.h, and there's the actual structure that we're interested in, input event. And this is the structure that will be sent to that driver that we can actually read. So anytime there's any kind of keyboard event, you can read it from that driver. So we're then going to need a file descriptor and open up that driver. So dev input event 0. We want to read only on it. ORD only. We need a file stream because we want to actually write character stream back to some file on disk to save the data once you translate the text. So this is a little different. I use fopen. It's going to be the log file that we define above. It's going to be A for append mode. What that does, let me just show you real quick. Remember, if you guys who don't really program in C, always use the man pages. They'll tell you all the relevant data for any function you need. So fopen, A is open for appending, writing at the end of file. The file is created if it does not exist. The stream is positioned at the end of the file. So that's what we want, because when we first run it, it'll create the file for us, and subsequently it'll append any new data, so it won't delete any data, which is what we want, or that's what I want. So now what I'm going to do real quick is I'm going to set up an endless loop here. There's much better ways to do this, but for now, just keep it simple. Let's make sure this works. We'll just endlessly read from that device driver and get all the keystrokes, all the data. So we're then going to read from the file descriptor that we opened above, which is associated with our character driver, the device driver. Read it into the event struct, the size of the structure, and now we need to know exactly what those types are. So, what is type, code, value, time? I mean, time's pretty obvious. It's probably the time that the event was generated. The rest of these, you can actually find their definitions in the Linux kernel documentation. Input.txt. I've got it here for you though. Struct input event. So time is a timestamp, as we guessed. Type is, as an example, ev_rel for relative moment. Maybe I meant movement there, I'm not sure. Ev key is for a key press, that's what we're interested in. So we actually want to trap any kind of key press. So, sorry, what was that? Type ev_key press. So we'll do something like if ev.type equals ev_ with key press, is that what it was? No, ev_key. Yeah. Where is it? ev_key. Okay. We're also going to trap what kind of key event it was. First, code. Code is the event code. For example, key backspace, RELX. I'm guessing it's relative X for mouse movements. And a complete list is in this header file. Let me show you that. So you can see here the code field in that structure basically just corresponds to whatever key you pressed. So if it's the R key, it will be a value of, what is that? 20, or 19, sorry. T will be 20, Y 21, etc. And if you notice, it actually will use your keyboard. It's like a QWERTY keyboard. So, you see here QWERTY, QWERTY. So it's not like A is 1, B is 2. No, it goes corresponding to your keyboard, to a standard US QWERTY keyboard. So that's the code. So we know we need to get that at some point. But also value is the value the event carries. Either relative change for ev_rel, absolute new value for ev_abs, ABS is joysticks, or a 0 for ev key for release, 1 for key press, 2 for auto repeat. So if we don't determine which kind of ev key we handle, you'll get repeating characters because you'll handle every one of them. So you'll handle it for a key release and a key press. So when they press the A button, you'll write out A. When they release the A button, you write out A again. So we only want to trap one of those. So we're actually going to trap 0 for release. So and ev.value equals 0. So we want to make sure the event type is ev key, and we only want to trap when it's the value of 0, which is the key release. And what we'll do, I'm just going to show you. Let's see that it works. Let's print out the code. Let's see if it compiles, which maybe it doesn't. It does. I'll print out its character. Let me print the decimal value. I don't know why I did that. So now if I type hello, HELLO, 35, 18, what have you. Let me just close this. And if we check out our event codes, we can see 35 corresponds to an H. 18 I'm sure corresponds to an E, which it does. 38 to an L, and so on and so forth. So I mean, the keylogger at this point is working. It just, we want to make it nicer so we can actually read it without having to reference this table. So let's open it back up. Let's actually make kind of like a character map. Be a character array. And oops. All I'm gonna do you see here, key reserved and key escape is 0 and 1. So we don't know what reserved is. So we'll put a dot. Basically, we're not gonna interpret it. We're not gonna interpret escape either. But the next one's 1 to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. We will. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Minus equal. We will take those as well. Backspace, we're not going to quite yet. Put a dot for now. Tab keys, same thing. We're not going to handle it yet. And then we move on to QWERTY, QWERTY, left and right bracket. So again, just straight down to here. Then it's enter and left control. We're not going to handle those. Dot, dot. And then we're down to the next line on your keyboard, ASDF, GHJKL, semicolon, apostrophe, and then backslash, which you'll have to escape. And then the next line on your keyboard, ZXCV, BNM, where's the rest, comma, dot, /, and that's all we're going to handle for now. And then, if I print the character of that code position inside my map, it should print the letter for us. Let me just get over here. HELLO. Now enter, it shows a dot. So let's try something else here. Gotta flush the output stream here, just 1 second. All I'm doing there is making sure that we write anything that's pending to write to our output stream, our screen, it will write it right away. So you can see it's not completely working because it doesn't interpret spaces, it doesn't interpret enter. Instead it's these periods. So let's fix that. I'm going to put a switch statement, switch on the code value. Now what we're going to do, we're going to get the value for enter. Which is 28. I'm going to make it a new line for now. And the value for space Oh, space bar, sorry. Where in the world is space? Oh, key underscore space, okay. 57. Otherwise, we'll default to putting out the actual character that it maps to in our character array, the map. So go like this. So now, if we say hello, space, so that works, world, enter. So now it's working as we'd expect. It's reading, and this is a completely different terminal, and it's reading what I'm typing. Let's say if I was to SSH, oh, whoops. Oh, I can't store my password. let's say I was to SU to my root user. You see my password right there. That's not my password, obviously, but you see why it's cool to have a keylogger. So the only thing left now is really to save it to our log file, and all that is just changing all those put chars to printf statements. So let me do that real quick, show you guys how to do that. We don't actually have to flush std out anymore. I'm going to change this to an fprintf into our file pointer. The string it takes. Like that. This will be a space. And this. Will be a character. And let's close it up. Close this as well. It should get released by system anyways. And let me just to make sure, I'm gonna flush the file pointer here, especially because I'm probably going to be sending a sig kill to it. Okay, so let's compile it. It works. Let me just check first. TMP data does exist right from an earlier time I tried it. Let's kill. Oh yeah, that's right. You've been creating it every time. Okay. So anyways, /. Let's run it. Let's SSH. No, let's SU. Migrate password. It's gonna fail. Let's kill our keylogger. Let's check our data. I hope it works. And so there you can see migrate password. I might hit the M. So now you essentially have a keylogger created. It can be a lot better, where you aren't handling some input, the dots. You can easily add that yourself. Not hard to put in. I think my M might be messed up a little bit. I might have it in the wrong spot. That's just a matter of checking the event codes, which again is right there, and just making sure the M is in the right spot, which it probably isn't, because I'm pretty sure I typed my great password. But there you go. Really super simple. Video ran a little longer than I expected. I'm sure the audio isn't great. I know I've got like a ton of complaints about that. I can't fix it yet. But I'm going to write an article pretty much every video now that you can probably use to follow along a little better, especially for guys who are just learning how to program in C, which